I'm Sai, a ninth grader, and I represent the Global STEM Academy. I wanted to do something fun for Science Day, so I decided to make a video about the science behind a cool toy called a kaleidoscope. Keep watching to learn what it is, how you use it, and why it even works in the first place. To start off our lesson, here's a riddle. Listening? You can see nothing else when you look in my face. I will look you in the eye, and I will not lie. Any idea? Here's a hint. You can find me in your mirror. Yes, that's right. I'm your reflection. We see our reflections every day, whether it be in the windows of our cars, the surface of our pools, or even our cell phone screens. But have you ever stopped to think, why? Why do we see our reflections in all these objects and not, say, the textbook? So, when a surface reflects beams of light, it is basically telling the beams, sorry, you can't go this way, and reflecting them back. This is why we need light to see things, because if there's no light, the surface has nothing to reflect. But, like we discussed before, why do some surfaces, such as our windows, reflect light, but some surfaces, such as our math textbook, do not? Well, it has to do with the smoothness of a surface. Some things, like our windows, are made out of glass, which are very smooth surfaces. Therefore, the glass reflects light waves in a parallel way, which results in another image. Rough surfaces, such as the cardboard that makes up our math textbook, do not do this. Instead, they scatter the light beams when they reflect them. So there is no image that can be created, and we don't see our reflection. Reflection from a flat surface causes what we call a mirror image. For example, when you look into a pond, what do you see? Yeah, your own face. There is one important difference between your face and the face you see in the pond, however. Can you think about what it is? Yeah, the directions are flipped. The right eye of this face will correspond to your left eye, and vice versa. So, if you think about it, this side is my right, but to you, it's your left. This is why it can be confusing when two people are standing in opposite directions and are talking about rights and lefts. It's actually just reflection playing tricks on you. There's a very interesting toy that helps us understand the principles of reflection that I've just mentioned. It's called a kaleidoscope. A kaleidoscope is basically a tube with several mirrors inside that reflect the light coming through. So when you put your eye in the eye hole that you can see here, the light that reflects will reflect among all the mirrors and also on the shiny objects, creating colorful patterns that are fun to see. You can even turn the tube around to change the light source and therefore change the patterns.
3, 2, 1, go.
Okay, so now let's get started. The first thing you'll want to do is fill your bead chamber with a lot of beads, which I've already done. Then take one of your color filters. I'm choosing yellow for today, and place it gently over the bead chamber. Now, take your kaleidoscope tube and gently press them together. Make sure that your bead chamber is secure. We're looking pretty good now. Next, take your 3 mirrors. Take some adhesive, which I have right here, and then secure the mirrors together like I was talking about before in a 60-degree triangle formation. Interestingly, the principle of physics that this entire kaleidoscope is based on is the law of multiple reflection. Because of this formation, you will never see an image in a kaleidoscope more than once, especially when tumbling it around. Okay, so I already secured 2 of these. I just have to do 1 more. Okay, so now we have our mirrors all set up, and we'll put them into this we'll gently slide them, so we can be kind of careful when you're fitting them in. Okay, so now we have your eyepiece and the eyepiece cover. So put the eyepiece cover over this and fit this over the other end. Make sure both ends are a little tightly secured. It's hard to push in at first, but just gotta make sure. Now, voila! You have a kaleidoscope. Make sure, look through the eyepiece and make sure that all the mirrors are in good position and that you can see all the gorgeous patterns. So there you have it, your tutorial on how to make a kaleidoscope and how reflection really works. I hope you enjoyed this video and took something from it. I'd like to leave you with this one last thought. We don't really think about reflection that much, mostly because it's such a big part of our lives. We see reflections in the mirror every day as we get ready to go to school or to work. We see mirrors and reflections in our car windows, and we're on our phones so much that we probably don't even notice ourselves in our screens. But looking at reflection from a physics point of view, and even from an analytical point of view, can teach us that reflections are so much more than just ourselves.